Hey, this is Dr. G, and I am coming at you with another video from one of my students. This one is about a model that has an interaction term. So I haven't done this before, but if you look here, your beta to the third, your beta 3, is your x1 times your x2. So I have this interaction term right here. With an interaction term, you can generate a single linear regression equation given a level of one of the interaction terms. So that's what this is asking for here. How do I estimate the slope of the linguistic delivery style when this x1 is 22? Now, I don't actually care about most of these things. I just want to show you how to actually get a single linear regression from one value when you have an interaction term like this. Now, if I click on this icon to view the results, it's in a pop-up. I've saved that pop-up here. So this is the data. These are my beta estimates, and these are my x1, my x2, and then my interaction term right here. Now, I only need the beta estimates because basically I'm going to build a linear regression equation, and I'm going to create a new constant and then a new beta estimate for just x2 given a level of x1, right? So I opened up my handy dandy StatCrunch. You can absolutely do this in a calculator. You can absolutely do this in Excel or Google Sheets. But StatCrunch is built into our Pearson system. And so let's go ahead and see what this looks like. What I did was I got my variable. So here's my constant, x1, x2, and then my interaction term. Here are the beta estimates copied from the sheet over here, 15, 36, 675, right? 15, 36, 675. And then here's the level that it wants, given that x1 is 22. So there's my x1 is 22. So how do I want to do this? Well, given that I'm doing this in StatCrunch, I actually am going to do a multiple expressions, okay? And you'll see why here in a second. And then I'm going to scooch this and make it smaller. So now that I've made this smaller, what I'm going to do is I'm going to put the constant here and I'm going to put slope here. Now, this regression equation actually looks like this. It actually looks like 15.86 times, plus, because that's the constant, plus the 0.036 times x1, right? Minus 0.675 times x2, plus 0.034 times x1 times x2. Okay? Now, I happen to know that x1 is 22. So what I'm going to do is I'm going to take out these x1s and I'm going to type in 22. So I'm going to take out the x1s and I'm going to type in 22. Now, what you'll notice is this portion right here is both numbers because the x1 is there. This is going to become our constant term. You'll notice that this number is being multiplied by x2 and this number is being multiplied by x2. That's going to end up being our slope. So what I'm going to do is I'm going to take this part here and I'm going to cut and paste it down here. Okay? So now this is my constant term. Well, these two have my x2 terms in it. Well, if these two have my x2 terms in it, that's my slope. So I'm basically going to factor out the x2. And now I'm going to get my constant and I'm going to get my slope. And I click on compute. And what you'll see is the constant part is 16.652. 16.652. And the slope part is 0.073. And the slope part is 0.073. So you can plug in the x value, the predictor that you need, factor out the factor that you don't have from both the interaction terms and get that. If this helped you, if this makes sense dealing with interaction terms, then that makes me happy.